Hosting provided by Host Tornado. They offer website hosting packages, dedicated servers, and VPS solutions. Host.t.net.
Programming Throwdown, episode number 8, Prolog. Take it away, Jason.
So I got some good news and I got some bad news.
That's the way they always come in pairs.
Yeah, it's true. It's this dichotomy. The good news is I got a smartphone, so I entered the 21st century. Yeah, that's right. I went through this issue where it's like, oh, I want the iPhone, and it's like, oh, I'll wait for the next iPhone, and then oh, I'll wait for the next iPhone, and just in this just perpetual paralysis. But I got to the point where with moving and needing a new number and everything, I felt like it was time to abandon my feature phone and go smartphone, and I'm loving it. I think it's awesome. I'm totally geeking out with it. The other day we had to walk to the post office, and we go there constantly. But I used Google Maps, and it kind of like gave you walking directions, and you could see yourself in your phone, see like a top-down view, like you're playing Pac-Man or something.
This is the honeymoon period.
Yeah, that's right. You're an expert on the smartphone, right?
No, I'm not an expert, but yeah, I remember first getting one, and you're like obsessed, and you get all these apps for it and all this stuff, and then eventually it kind of lulls out and you get bored of it, and then you kind of settle into like a good routine where you're not overusing it. But it sounds like probably maybe too nerdy or overly dramatic, but I feel like it changes how I do things. Like I look up stuff. Today I was at the mall with my brother and my wife, and my brother said, "What is this?" or something. Some shirt had some phrase on it we didn't know, so I just looked it up. I'm like, not gonna wait. I would have normally forgotten. Now I know what it means. It's useless,
Yep.
But
one cool thing we did, we were at Sports Authority, and we were looking at sport watches because we've been doing a lot of running lately, and so my wife and I, and so we there was this one sports watch, and I took a picture of it with Google goggles, and found like it was cheaper at Kmart.
yeah, be careful of doing that. So I do this all the time. Amazon has a barcode scanning app, and it'll tell you the price on Amazon or anywhere else. And I got Amazon Prime, so I get free shipping always and 2 days. That's pretty good, right? So
yeah, that's one thing. Sorry to interject, but if you're a high school or a college student and you have an EDU email address, you can get Amazon Prime for free. So definitely
you should do that. Also, I think caregivers like stay-at-home moms and some, I don't know, there's a bunch of people. I don't know how many stay-at-home moms we have listening to our podcast, but
I don't know, hundreds,
okay,
thousands.
But yeah, so you go to the store and you're like looking at something on Amazon, so that's great because you're like saving money, right? Like I'm just gonna order it on Amazon or even right from my phone and get it in 2 days, and that part's not bad. That's good. Okay, the bad part is sometimes you want to buy it or you need to buy it because you need it kind of right then for something, but you see the reviews, and if you look at the reviews for like half to 3/4 of stuff in the store, like going through Target or Walmart or Kmart or whatever, or like that watch, right? You scan it and you look at the reviews online, and you'll find out it's terrible, and then you won't buy it. And in the end, it wouldn't have. Well, maybe a watch is a bad example, but like a T-shirt, and it's like, oh, this T-shirt, starts to lose threads really fast. It's like you wouldn't normally care. But now because you see the reviews are 2 stars on Amazon, you don't buy it.
Oh, I see what you're saying. I think that on the contra is the opposite is also true though. I noticed that like a lot of mom and pop restaurants that
same thing.
They always say that like the ugliest looking mom and pop restaurants have the best food, but it's like at the same time it's like it's like you never know what you're gonna get, and you can't really sue them for millions if it's just a mom and pop restaurant. So they have less on the line than like a McDonald's or something, which has to cook your food right, But Yelp really helps there, or other apps, if you find a place that's rated really well or a place that's rated really poorly, it could really influence your judgment.
Well, but it leads to the same analysis paralysis, because you'll be somewhere and there'll be no good reviewed restaurants around. So you won't, it's like, where do I go? There's nothing good. So you'll like drive really far to go somewhere that's good, even though it's really not that. I don't know. It's just about being unique, because people on Yelp, for instance, will pan a McDonald's or a Quiznos because it's a chain restaurant and they prefer independent restaurants over chain restaurants.
Yep.
On average. That's my opinion. I have no idea if that's true.
Yeah, definitely. I think that there are what's the word? like
Biases.
there are yeah, exactly. There's an internal inherent bias to people on Yelp and on these sites, especially people that review them, not so much patrons. But I feel like as the barrier of entry to reviewing things goes down, like for example, you have your smartphone and it has a GPS, so it knows. So it could even just be smart enough to know you went in a restaurant and came out, and know that you were there for an hour and just say, hey, why don't you write a blurb about this restaurant? And as it becomes that easy, I think you'll get a more diverse population doing reviews. But as it is now, yeah, a lot of kind of hipster people who are really against the man and chain anything. A lot of those people are the ones doing the reviews.
Yeah, I actually saw. So this is a really interesting thing too, and we didn't have this in our news, but it is interesting. So I'll talk about it now. Where they did a study saying people are really well. I guess it's kind of like people are really bad at predicting what they're going to want in the future. So they were taking for Netflix. If you ask people, like, you can build a queue in Netflix, and these are the movies I'm going to watch in the future, and you'll put like all these highbrow movies on, like artistic independent films. But then if it actually comes time to watch a movie, you watch like stupid, silly movies that you just want to watch to have a laugh and aren't serious and don't make you think. But in the future, you think you're going to be like a smarter person. You're going to read these fancy books and watch these, really intelligent movies, but you don't end up actually doing that. And it's the same thing I think happens on Yelp, where people want this idea of eating these nice restaurants all the time. But in reality, most people just end up going to McDonald's and Quiznos and Subway because you just want something what you're going to get.
Yeah, because if you think about it, planning in general, like planning ahead and thinking about the future, is kind of hard. I mean, that requires like a lot of computation. That gets into the area of the brain that does like really hard, complex stuff. And so probably when you're in that mode, you're more apt to like look at something intellectual. But then the spur of the moment, like, oh, I want to watch a comedy, kicks in, like an interrupt or something. And so yeah, you're just not accounting for that.
So welcome to the world of smartphones. That is good news. Maybe now you'll be able to respond to emails a little quicker and be pestered all the time with interruptions.
Yeah, definitely.
So you said you had some bad news too?
It's been pretty awesome. Yeah, so the bad news... Am
I going to cry?
So I got they installed a bike rack in our complex, which I thought was great. And
that's not bad news.
I left my bike there, and after 2 days of leaving my bike there, it was stolen. Someone had cut the... Yeah, the bike rack was inside of our garage, which requires like a clicker to go in and out of. So our hypothesis is that somebody just kind of snuck in behind a car, and then, once you're inside, you can easily get out. So they just stuck in and took our bike. I bought one of those cheap chains that's just like several steel, threads that are kind of woven together, and so they just cut through that.
Did you see it? Did it get picked, or did they just cut it?
No, they cut it. Yeah, they cut through it. So, because I had it was a frayed end, on. They left the chain there.
Well, that was nice of them.
Yeah. So, it really sucks, but this actually brings up a really interesting point. See, I just bought the bike, and I paid with my credit card, and so most, just about any credit card out there has an automatic purchase protection insurance. It's free. You don't have to pay for it or sign up or anything. It doesn't cost any money or anything like that. And if something is lost or stolen or damaged within I think it's 100 days, your credit card company will actually reimburse you. So you can actually, you could buy, let's say we went and bought this watch and we paid with our credit card, and we throw the watch off a bridge.
Well, be careful. I don't know if you actively throwing it away might change things.
Yeah, I guess you can't be that bad.
If it fell off and got crushed.
Yeah, if it fell off your wrist off a bridge, or it get crushed under a car or something. Even though it's an accident, and even though it's technically, I guess it's nobody's fault. But I mean, the fact is, it's not the manufacturer's fault or anything like that. They'll still refund you the money. So I have another friend that this happened to. He bought an Xbox, and someone actually broke in his house and they stole his Xbox and his TV. But because he had bought the Xbox within 100 days, he got reimbursed for that. So if ever something like that happens, definitely take advantage of that.
Well, at least check. It's worth checking then for sure.
Yeah. I mean, we had to file a police report and a bunch of other things. So, it's not just what's the word? I guess it's not a panacea. It won't cure all of your problems. But yeah, it's not a free pass. That's right.
Yeah, but it's definitely
But
something good to know so that you can check on it if it ever happens to you, which hopefully it
yeah,
doesn't.
yeah, definitely keep that in mind. So I'm kind of glad that whoever had that intention was quick about it, because if they had waited another like month or so, then I wouldn't have been able to use this option. So yeah, it kind of sucks, but I can. I have my wife's bike that I can use to get to work
And
in
it's
the
pink and
meantime.
has a little horn and those little
it
frill
it
things out the
it
side.
has one of those baskets because she uses it to go to like to the supermarket and stuff. So
Aww.
yeah, it has a basket. It has those like really like soft, flat, cushy seats. It's
Powerpuff
definitely
Girls
not.
on the wheels.
It's so
I guess your
girly.
wife isn't like. Oh, I was gonna say a really young age, but that would sound really bad. So, anyways, just forget that.
No. She it is green. It's kind of like a green mountain bike, so she's not a too girly girl, which is
Okay.
nice. It's not like the pink DS that I have to put up with.
Oh, all right, all right.
But
So,
but yeah, so that's the bad news. So you doing anything cool for 4th of July?
yeah. So by the time people are listening to this, we'll already have done it. So, future me in the past has done.
That's right.
Yeah, I already hung out with some my in-laws yesterday, so that was good, and had a
Cool.
good time there. We played some board games, Wits and Wagers, which is fun, and we played some Wii, which my grandmother came over and she beat me at some of the Wii games, which
Wow.
is really embarrassing. Ones I never played before, so I didn't really know what I was doing. And that's just an excuse. So she's really old and she beat me. So if you're listening, Grandma, congratulations again. I'm still mourning that loss. And so that was
Oh,
a lot of fun. And then we had some barbecue. And tomorrow going over to my parents and grandparents and probably do some more barbecue and hanging out. Maybe we'll play some board games and stuff. So I don't think we're doing any fireworks or whatever. I used to be really into that when I was younger. Even though my parents said it was kind of like burning dollars and I might as well just light money on fire. They were pretty harsh about it. Anyways, but
yeah, we used to do crazy stuff like make napalm, and we used to buy the magnesium strips and make fireworks and all that back in the day.
yeah, nowadays you probably get in trouble with the Patriot Act, all that stuff. But
Oh, that's true. That's true. Nowadays things have become very tame. Like I went to get a chemistry set for my cousin's kid. It's his birthday, and it actually advertised that you could eat everything in the chemistry set.
that was a good
It's
thing.
like, yeah, it's like everything's edible, and I'm like, what? I had a chemistry set when I was a kid, and it had, well, stuff, for example, stuff to make fireworks, and I'm pretty sure that stuff's not edible. So
Wow.
things have become much more tame. So it's kind of a sad
I
thing.
know you can still do, at least in Florida, they still have model rockets, so that's kind of cool. But
Yeah,
I know
yeah, I
that's
think they
quickly
they
kind
have
of
that
fading
here.
away too, which is kind of sad.
Yeah, it's a shame.
So what are you
But
doing? What are you doing for the weekend?
oh, so we're actually gonna go into the city. We're gonna go to San Francisco, um, and we're gonna see they have a fireworks show, and we're probably gonna try and grab some food and check out the Museum of Modern Art and stuff like that.
Oh, cool. So I guess we should
So
explain for anybody not from the U.S. who's might be listening, since I like to think that we have listeners who are international.
yeah, for sure.
But yeah, so 4th of July is the independence of the U.S. From the rule of Great Britain. And so on the 4th of July, we celebrate that typically with like fireworks and a day off of work and grilling and barbecuing, that kind of stuff.
Yep, if we have any listeners from Canada, this is the equivalent to 1st of July or Canada Day.
Yep, that's right.
But
So
yeah, it's basically a chance for everyone to get together. They shoot off some fireworks. You get a chance to sort of be appreciative for like all things that we have. This is one
yeah,
of the things that we were talking about today. It's like the it's true that like you get good things and bad things happen, like the bike getting stolen, things like that. But overall, I feel like we're really lucky. And one of the things
definitely.
that makes this place so lucky is that you have open access to technology. Like you have geeks like us who will tell you about programming, and you have Wikipedia and the opportunity to learn just about anything, and no one's stopping you from learning anything you want and from being as eclectic as your capacity. So yeah, definitely go out there and have some fun and celebrate.
Yeah, definitely thankful for all of our soldiers overseas, protecting our freedom this time. So I know
Yeah,
there's
for
some
sure.
controversy there sometimes, but definitely supporting the people who are out there, in harm's way. So
Yeah, I mean, different people have their opinions what is worth risking life for and things like that. And with all that aside, anytime somebody puts their life on the line for anything, it's something that should be taken very seriously. And there's
Hmm.
a lot of people who are putting a lot on the line to, keep a lot of this stuff going. So,
So news.
yeah. So on a lighter note,
So I guess the first news article is one I put in there, and I guess it's not really news. Maybe I should have shifted that farther because now this is going to sound silly, anyways. But this is an article I read. I guess it actually came out a couple weeks ago,
Mhm.
or at least I saw it a couple weeks ago, and it was a guy writing about the difference between a developer, a programmer, and a computer scientist. And hopefully I'll get this part right, but it's the idea that was kind of interesting. And his
Yeah.
thing was that a computer scientist, and he was saying that all of these categories, these classes, are necessary. And then the computer scientist is kind of the guy who's out there thinking about things. He's really math oriented. He proves
Yeah.
out whether something's optimal or not.
He has elite math skills, but in leet speak, he has 31,337 math skills.
Yes,
That's
that guy.
awesome.
Uh,
If nothing else, everyone should read this article just for that. That's pretty epic.
and then a programmer is kind of the step down, somebody who's still into the architecture and the higher level programming. They're very efficient at things. They may not know how to prove it emphatically, guarantee that this is the best, but they know about how it is, and they've got kind of maybe one or two areas where they're really really experts at, and they're good at everything, but kind of key. And then a developer who I guess I might change this and say kind of coder. But a developer is actually a little more higher than what I would consider just a coder. But a developer is somebody who writes code, but they're kind of like a generalist. They just work and they're really good at the art of writing code, as opposed to necessarily the algorithms or data structures. And so they're more used to working with like maybe frameworks and the glue code and integration of stuff and kind of testing. And so he is saying that there's all these three different classes that they're kind of related. They have a lot of overlap. And it was just kind of interesting thing. It made me think about, and you and I have had this conversation before about the different classes of people in the programming world and about how that all of them are necessary, but that some are probably considered more highly than others. Janitors are really important. We really need janitors, but people don't always give them the respect they deserve. And I think some of the classes of computer programmers are similar.
Yeah, definitely. I think that it's a really good point. And the other part of it that's really interesting is that, a computer scientist is, it's really interesting to think about how experience relates to this, like experience versus knowledge. A computer scientist could have a lot of knowledge, not necessarily so much experience.
Yeah, that's a good
But then
point.
at the same time, they need that experience. So a computer science with experience is still a lot more useful than one without, even though they're doing a lot of theoretical.
Yeah.
And so, same for all of these is that there's just this balance you have to strike between, getting a lot of these skills, picking your path and gaining experience in that path, but also having a wide breadth of knowledge.
And I think it's somewhat of that plays into what happens to everybody first day on the job. I remember first day on the job as a computer science guy. Not a summer job where I was just flipping burgers or whatever, but first job actually in the career workforce, and you kind of get in there, and first few days you're really timid. You don't say much. I'm kind of an outspoken guy, and so after a few days you start saying stuff, trying to show that you know what's going on. And then for a while you think, wow, I'm smarter than all these people. And then a little bit more time goes on and you realize you probably have knowledge about things they don't, newer stuff that they maybe don't know about yet or haven't looked into. But they have a lot of experience that teaches them how and when are the best ways to apply those bits of knowledge.
Yeah, definitely. Yeah, I mean, they have a lot of one key thing of it is that they have many points of reference. So, you might jump into a project and say, "Oh, this is going to be a piece of cake," and then you hit this snag, and it really throws you off. The next time you go into a project, you're a little bit more wary. You say, "Oh, I'm not going to say this is going to take me a week because there's a chance that I might hit some snag," or last time I hit this snag, so this time I'm going to look and see if the future is going to be rocky. Like if this can happen again,
Yeah.
and if there's a chance that it can happen again, I'm going to make sure that people know about it. There are
Yeah.
things that you can only learn from learn the hard way, I guess.
Yep. Yep. School of hard knocks. That's the phrase.
Yeah, that's right.
So I should apologize. My voice sounds a little bit funny. I've been getting over being sick, so I apologize in
Oh, I thought it was
advance.
all the clown training.
That too. But riding that unicycle, and I tripped and ran into one of those elephant platforms on my trachea. It was really bad.
Oh,
Uh,
rough.
but no, so I apologize for that. I promise you can't get what I have over the podcast, so don't worry. You don't have to wipe down your headphones. But anyways,
Yeah,
yeah,
you
I do sound a
actually
little bit funny.
you can't contract diseases through social networking, although you are very close to some people and not so close to others.
Yes.
Which
Okay.
which kind of leads to our next article, which is Google's social networking platform, Google Plus.
Google plus what?
Google Plus Plus.
Oh, ooh. Sounds like a programming language.
It does. Maybe they'll have an API and it will be.
Okay,
But
stop.
I think that yeah, next show is Google Plus Plus. No, I think that Google Plus is come out and a bunch of people are getting in on it. I believe that they were doing invites,
Yeah, it's
but
closed
now
down
they've frozen
now. Yeah, I'm
invites.
waiting
Yeah, I
in that
guess.
long line. So,
Yeah, same here. I guess they're gonna reopen invites pretty soon.
but I did look at a bunch of the like videos and stuff other people who were in had posted.
Yeah, yeah, definitely. One of the things that is just really, from what I understand, and I've seen a few news articles on it, and the big fundamental thing that keeps popping out is this idea of the circles, where it's now, I think the word is asymmetric. So, in Facebook, it's symmetric. So if I'm friends with Patrick, Patrick's also friends with me. But in Google Plus, it's asymmetric, which means, I could have Patrick in my friends circle, but he doesn't necessarily have to do the same to me. And so I can post to all of my friends, um, and when they post to their circles, it may or may not come to me. And this is kind of cool because there's there's a lot of people who might want to friend you, and you either like don't know them very well or they're acquaintances. And there's other people who are like your family, where if you're having a baby or something, you'd want to tell them. So there's these different categories of friends. There might be some people who know you, but you don't know them. Maybe someone you went to middle
So
school
it's kind of
with
like
who
you're tagging
recognizes
them,
you.
right? So like the circles, you're tagging people of like what kind of friend they
Yeah.
are.
So this way, the fact that it's asymmetric, I think, is actually a huge bonus. I mean, for
Yeah.
me, the thing that killed Facebook was when my grandma requested to be my friend. I mean, that was kind of the end of Facebook for me. I really did, it's like I can't tell her no, but now I can't post rude jokes on Facebook, and it gets to the point where it's like you can't really do anything useful.
Yeah.
So
So that'd be cool.
I
So
think
definitely something to watch. We'll see how it goes. I guess they've had a couple forays, and I know that's a big thing for them. They want to get into social networking, and so
yep.
hopefully this will be different. When I get on, I guess or you get on. When either of us, we'll be able to give a little bit more detailed report.
Yeah,
Say
for
what it's
sure.
like.
One interesting thing is historically, if you look at things at Google that have been blocked by the Chinese government, they've been the popular things. Like Buzz didn't get blocked and Wave didn't get blocked by the Chinese firewall, but Google Plus was immediately blocked by the Chinese firewall.
Oh, so
So
maybe they're like precognizant of how good it's
yeah,
going to
that's
be.
right.
They're forecasting.
Yeah, it seems like if you use the Chinese firewall as a predictive model,
So
that
I need
Google
to
Plus is going
create
to
a
be very
hedge
popular.
fund that has this in mind.
Yeah, yeah. Create a fund
Speaking
that
of speaking of finance and social networkings,
yeah, that's
our next news article is Zynga going for their initial public offering, which means that they're going to try to sell stock shares of the company in order to make
Yep.
some money. And, there's a way for the investors and stuff to cash out. But one of the interesting requirements that the United States has is that in order to be able to do this, in order to be able to sell publicly portions of your company, to do that, the people who regulate that, the Securities Exchange Commission, requires you to release information in a certain manner and in a certain way to basically protect the public to know what they're investing in and know that that's been, kind of regulated and checked. So people they can't lie about how much money they make or be completely secret about what they do. And so Zynga filing for their IPO means they had to release numbers about like how much money they make, where they make it, that kind of stuff. It doesn't mean they have to spill all of the details, but more details than they have previously. And so one thing that was learned is that they have a special contract in place with Facebook. Oh, so we should explain, I guess. Zynga is the company that does a lot of the social networking games on Facebook and other places. I think now they even do stuff not on Facebook, but like Farmville. I don't know what the other ones. I actually don't know that I play any Zynga games, but
Yeah, I think they have one where like you build a city. I don't play any of them either, unfortunately, but
I
yeah,
think
they
that
have several.
yeah, and I think they have like a poker playing one. They have a whole bunch, and their key is is to have it to where you do better in the game, or a portion of the game is getting other people involved. So like you and I both being like friends in the game means we both do better because of that, but it keeps us both playing the game. And then to do like progress faster, you can pay money to basically go faster, even though the game is free to play normally.
Right. Yeah, it was actually really interesting. I was reading another article where they were discussing how they reported the income. And because apparently, like, they had to, because the Security Exchange Commission was kind of like, they have all these different, very segmented types of income. And they actually treated things you buy online, microtransactions, as actual things. So, for example, um, let's say you buy a tractor in Farmville. So they actually count that as a capital investment, as if the same as if you bought a tractor from Home Depot or something. So a capital investment versus you paying for a service. So for example, if you buy ads on Google Ads, that's a service. You're paying for them to show you these ads. But when you're buying a tractor, even though it's just ones and zeros, they're considering it a capital investment, and they've estimated how long people play on Zynga. The average user, I think they said, plays 18 months before stopping. Um, so yeah, I know, isn't that crazy? So they basically said they're leasing you a tractor for 18 months in game, but they're treating it as a real tractor on paper.
Well, yeah, I
And
guess
it's just
there's obligations that come with that, right? Like they can't not have the server. Excuse me. They can't not have the server that has the tractor on it anymore.
right. That's right. So they're forced to provide the tractor for at least 18 months because they've made this claim on paper and things
Wow,
like that.
that's interesting. But yeah, I
Yeah,
think
it
that's
was
pretty cool
fascinating.
that Zynga's got kind of they're tied so closely with Facebook at this point in time. I've heard the converse as well. Facebook is alleged to go public soon as well, do their IPO, and people are
Yep.
saying Facebook makes a lot of their money off of Zynga. So it's kind of
Yep.
interesting. These two companies are really symbiotic at this point.
Yeah. Yeah, definitely. I have kind of an interjection news article. I didn't post this, but I will bring this to everyone's attention. This is kind of a shocker, but California, so as you know, I moved to the Valley not too long ago, and one thing that California is known for is having a lot of taxes, and they've decided to start charging an online sales tax. Have you heard of this?
No, I heard something similar about not people who are associates for like Amazon having to pay taxes on the money they make, so they just stopped having them. But this sounds different.
Yeah, basically, if I understand this correctly, and I don't know if it's been passed. It says passed, so I guess it's done. But basically, if I, yeah, as a California resident, buy anything online, regardless of what state it's in or anything, I have to pay sales tax. So
Wow.
that's yeah, that's really.
Well,
I feel
I
like
think a lot of states have had that for a while, but they just really not been enforced.
yeah, that's a good point. And this one might be also be equally hard to enforce. But I think that this, like, on the surface, your first reaction is, this sucks because I have to pay more taxes or whatever. But looking at like the bigger picture, I feel like this is sort of a good thing in terms of the macroeconomics, because the brick and mortar places are really just getting shafted. I mean, like, if Amazon can sell me something for less because they have this distribution network and it's on demand, and they have free shipping with Amazon Prime, which we just talked about. There's not really any reason for these brick and mortar places to exist. But yet there is a reason for them to exist, because often people want artisans. So for example, um, you might want fresh produce. Like, you might want fruits and vegetables from a local garden instead of getting them you know through some distribution center in Kansas. And so by not charging online sales tax, you really sort of screw all of those people essentially, and they can't, they can't function. So, but at the same time, everyone, not really too fond of paying more taxes. So it's really a double-edged sword.
Yeah, I mean, we could go into this a long time. It's not really the right podcast for it, but yeah, there's a lot of economic considerations, and I have actually kind of a lot of opinions about online sales tax or not. But yeah, we probably should punt on that so that we don't. That's not why people tuned in.
Yeah, good point. It could probably take a long time.
So no, that's good what you said. It just I don't want to bite on that hook.
Yeah. On a lighter note, I was walking to a grocery store in the area, and I happened upon this sign, and the sign was really fascinating. Right in front of a grocery store, it's site of first silicon device and research manufacturing company in Silicon Valley. The research conducted here led to the development of the Silicon Valley, 1956.
Oh.
And little did I know, but the grocery store right next to my house is the place where the first transistor was built.
So not invented, but like the first ones were produced or whatever.
Right. I believe the guy who invented it, he invented it at MIT, but then he moved back to Silicon Valley because he originally went to Caltech and he moved back home, and built and started this company that built the first transistor. So.
Well, that's pretty cool.
Yeah, I thought that was pretty neat. So if you have a chance and just want to do some light browsing, check that out. It has a whole history of the transistor.
I'll get read about Jason's grocery store.
Yeah, that's
Are you listed as a notable patron of that grocery store?
Not notable.
Well, we should go add that.
Yeah, we should.
Co-host of Programming Throwdown is a regular
Maybe
visitor.
I'll make my own sign and put it right next to that sign.
Okay. It's time for the tool of the biweek.
Tool of the biweek. So what's your tool?
So my tool of the biweek is Evernote. And Evernote, I guess it's still a tool. It's kind of a service and a tool mixed into one. But it's basically a note-taking note-taking program. And it's really nice because it's supported on a lot of different platforms. They have like a one for your PC. They have one for your iPhone, your iPad. I think they have it for Android devices, maybe even your Nook. I don't know. But they have it for a lot of platforms. And what it does is there's, mostly like what a note-taking app should be. You're able to just say, hey, this note or that note. And what it does is it syncs them between, so you have like an account, and then it syncs them between the different platforms. And so that's really nice that you're able to, make a note in one thing. Like I might be on my iPad, using my iPad on a plane, and so I'm not online. And I might type a note into my Evernote. And then later when I'm on Wi-Fi, it can sync that up with my iPhone. And then I can have it on my iPhone. And then if I get on my computer and it's like something I need to look up online, I can bring it up and already have it and just copy and paste the search term or the website or whatever. And so That's pretty cool. They also do some interesting things where you can take like audio notes and even you can take a picture of something and have that be the note. And one of the interesting things about that is they actually run like OCR, optical character recognition. And so when you take a picture of it, it'll actually like try to figure out what the text says. So like it was a handwritten note, or I take it like a picture of like a price tag or like a sign or something. And then when you search through your notes, it'll actually return those results.
Oh, nice.
Yeah, so that's all really cool. It's also like a generally really useful device to have. And it's free. There is a limit. I think if you use, and I don't know what it's the amount of documents you store or how many you do per month or whatever. I've never hit it. And I think it goes to like $5 a month or like $45, $50 for the year. If you go above a certain like megabytes of usage per month.
Okay.
But I've never hit that, so it works really well for what I use it, and it's completely free.
Yeah, here it says you have to go over a gig. So.
Okay. Yeah.
Most people are probably under that. So.
Yeah, so I think it's one of those things that almost everybody's under that, and just to keep people from abusing it. But some people choose to support because it is so useful and so cool. So some people choose to go ahead and use it anyways. Oh, the other thing is totally it does awesome. Like a geolocation. So when you write a note, you can see where notes were written, which is kind of cool.
Oh, yeah, that's really useful. So it's like you find restaurant that you really want to go to, but not that day, you can just make a little note, and then later on you can have directions to it or something.
Yeah, not maybe it'll do that. I don't know. That'd be cool. But I haven't tried that. But it notes where you make the note at, like
Yeah, well, I
like
mean,
at my
like if you're in
house or
front
at
of the,
work, so I
like you
can
walk
like
by a
send.
restaurant and you
Oh,
say, I
okay,
really
yeah,
want
yeah,
to,
that's
yeah,
true.
yeah,
Yeah, yeah.
yeah, yeah.
All right, what's your
That's pretty
tool?
sweet, man.
Tool of the bye week.
My tool of the bye week is FreeNX, and actually, it's, in more general, it's just NX in general. But the free version is almost 100% fully functional, so you can jump on that. And basically, what this is a way to do remote desktop, but it's a way that's extremely efficient. So a lot of people have used, the Windows Remote Desktop or VNC, and the way these programs work is they take screenshots of your desktop. Or I guess another way of looking at it is they make a movie out of your desktop. And so, as you open Windows and move them around and things like that, they're streaming a video of your desktop over to you. And because your desktop usually doesn't change that much, they could do this fairly quickly, and they could use all this compression and things like that. Now, on the other end, there's something called the X Windows system, which is the Windows system that Unix and Linux computers use. So, Windows has something called Arrow, which when you actually move the windows around on your Windows computer, you minimize and things like that, there's an engine there that's controlling all of that called Arrow. On Mac, there's one called Cocoa, and Cocoa is handling the minimizing, and Cocoa looks pretty cool. When you minimize something, it like shrinks down into the bottom right on your Mac, and that's all done by Cocoa. On Linux and Unix machines, they have something called X Windows. And X Windows has X forwarding. So what it does is instead of sending a video of your desktop, it sends commands over. So it says, hey, open a window. Hey, move this window. Sometimes it will send pictures. Like, here's a picture. Now put this picture on the window over here. But it's mostly, like 99% of it is just commands, text. And, just to put it in perspective, a dictionary of text, like a dictionary with every word in the English language and everything it explains, would be, what would you say, Patrick, like 5 meg or something of text?
Oh, this is a good question. I should know this.
Oh, wait, let's do some math here. Let's see. So let's say a
But
dictionary
keep going.
has,
I'll look it up while you keep going.
yeah, let me just take a guess. Let's say a dictionary has 50,000 words in it, and each word has like 100 character definition. Then that's just 4 megs of text, right? So you can write a lot of text for 4 megs, versus 4 meg is just a handful of pictures. So X forwarding is much better than VNC or Windows Remote Desktop. But X forwarding has a number of flaws. It's very old technology, and it doesn't really support modern operating systems and modern with their fancy effects and things like that. So if you run X Windows, it's not going to look very sharp. It's going to look very dated. So this NX technology is a completely new protocol, and it's been implemented in every architecture. So to do X forwarding, you have to be on Mac or Linux. But to do NX, you can do NX on Windows. So it's completely cross-platform. And it's much better than VNC and Remote Desktop and all these things for the reasons I mentioned. It's just the compression is much superior. And in addition, it's also secure. It runs over SSH, which means that, for example, let's say you're using VNC or X forwarding or any of these, and you're using a browser inside of a remote desktop session. So you're at home, or you're at work, let's say, but you're logged into your computer at home and you're using the internet there for some reason. If you type in your Gmail password, those keystrokes go across the wire, unencrypted. So someone listening on the wire in between your work and your home, or someone on your Wi-Fi if you're at Starbucks or something, can just see your password in plain text. But if you're using NX, everything is encrypted, so they can't do anything like that.
Well, there are a lot of ways to encrypt VNC as well, but the default configuration, yeah.
Yeah, you can encrypt
we shouldn't allude that anybody using VNC is unsafe. I mean, there's a lot of ways to get around that.
Right, and the same is true for X forwarding and remote desktop. So yeah, I guess that we should add that caveat. But with NX, it's built in. You don't have to do any tunneling or anything like that. It's built from the ground up to run over
Yeah, so it looks like there's
SSH.
clients for almost everything, but it looks like the server, so like what computer you're actually using, is restricted to Linux and Solaris.
Oh, really?
Is that am I? That's the
Oh,
website I'm on.
you know what it is? This is correct. So FreeNX server is a Mac, Linux, or Solaris only. To use NX Server on Windows, you have to use the paid one. So
Okay.
basically, a bunch of nerds made a free version of NX called FreeNX, but they didn't make it for Windows. Oh, but if you get, okay, this is another thing. The people who make the paid version of NoNX, they have a free version as well, the NX Free Edition, and I believe they have a server for Windows maybe. And oh no, they don't either. Wow, that's
All right. Well,
surprising.
but if it's for a computer that you have, you should check it out for sure. Yeah, this sounds
Yeah,
cool.
definitely.
I have to look
Yeah,
into
I mean,
this.
if you're running OS X or Linux, and you want to, get at your computer across the network or something like
And
that, this
so
is
it works
definitely the
really
way to
well.
go.
Not a lot of lag or anything.
No, it works extremely well. It has a setting where you can sort of dial it down based on the amount of bandwidth that you have. Um, and I recommend, this is a good point, I actually recommend putting it on the middle setting. So even though, for example, going from my desktop to my server inside my own house, I had it on the max setting. And that wasn't a problem, but I noticed that if I put it on the third setting, the internet usage went down dramatically and it looks almost exactly the same. So I think on the highest setting, it's not even compressing the images, like it's just raw images. But in the middle, it uses like a lossless compression. So you really, have nothing to lose by going there. There are a
Awesome.
couple of threads talking about how there's no NX server on Windows.
Okay, so maybe that part
But
wasn't completely correct, Jason.
yeah,
We'll have
sorry
to
about
print a
that.
retraction.
Yeah, yeah. We actually said something wrong. This actually is extremely rare. We usually
Oh,
only
whoa,
say
whoa, whoa!
something wrong.
I don't know. That's a bold statement, sir.
I think this might be the first time. We
Oh,
should
oh,
we should have a cake.
we're gonna get hate mail.
No, but it looks like I think some people are working on NX Server on Windows, but it doesn't look like it's there. But if you have a Linux server, and why don't you have a Linux server? You should definitely be running NX Server. If you're a guy who's been using X forwarding or VNC, definitely check this out.
Yeah, very cool.
Yeah,
I think that's it. So is it time for Prolog?
I think it's time for some Prolog. So Prolog is definitely a computer scientist's language.
So
No
so what does
developers or
Prolog stand
programmers
for?
here.
You gotta start off. I
Prolog,
don't know.
I think it stands for Programmable Logic, but
Yeah, I
I
think
don't
that's
think
right.
it,
That's right.
yeah, I don't think it actually,
It doesn't
you know,
actually stand for anything. No, it
yeah,
stands for programming logic.
yeah. But that's definitely what it is about. And so to talk about programming or to talk about Prolog, we have to talk about predicate calculus, specifically first order predicate calculus and first order logic.
Well, so
So it's
why
going to
why
be,
why did you
oh,
say
go
it
ahead.
was a computer scientist program? Are you gonna tell us that?
Yeah, yeah, definitely. We'll
It's a
get into
bold
that.
statement. Oh, okay, all right.
Yeah, this is so, this is going to be pretty geeked out, but we're going to, break it down and we're going to explain all the details. But first there's something called logic. And logic comes down to many different things, but two of those things are deductive and inductive reasoning. So, can you give me an example of inductive reasoning?
So inductive reasoning is building up from something smaller, right? So like inductive reasoning would be like dogs have. Oh, that's a bad example. I'm trying to think of an example that's gonna
Put
always
you in
be
the hot
true and
seat.
not just in a restrained example. But I only go outside when it's raining. It's currently raining, so I go out. I only go outside when it's not raining. It's currently raining, so I won't go outside. Did I get it
Yeah,
right?
kind of. That's kind
Okay.
of. So,
That's a bad example. Do you have a better one?
yeah. So, for example, inductive reasoning is essentially guessing. So let's say for example, okay, I live in Silicon Valley, and it's the it rains like zero point 0.1 centimeter for the entire month of July. Like it never rains in July statistically. So that's an inductive statement. So, it has rained in July at some point, maybe 25 years ago or something, but it's so infrequent that I induce that tomorrow it's not going to rain, which is, it can be wrong. It's not 100% true, but I'm making an assumption. I'm inducing that it's not going to rain tomorrow based on all this prior history of it, never raining in July or raining so infrequently. So
Okay, so you're making a prediction about the future.
right, that would be induction.
Okay.
Now, deduction is where you deduce, where you come up with new facts based on existing data. But deduction doesn't involve any guessing. So, for example, all mammals have hair, and Patrick and I are mammals, last time we checked. And so, therefore, we deduce that we have hair because we are in the set of mammals, and anything that's in the set of mammals has hair. So you can think of this as like a transitive property. Like we are in class A, and class A implies fact X. Therefore, we have fact X.
Yeah, that was what I was
deduction.
doing. I messed that up. I got it
Yeah,
wrong.
no worries.
Wrong. Tell me I was wrong. All right, second time. Crap. In one episode.
In one episode, man.
Sorry.
What the heck?
All right.
So, anyways, from this you can deduce that I'm never wrong and Patrick is wrong twice.
You have to induce about it, but you could
actually
deduce.
I was wrong the first. Okay. So now we have deduction. First order logic is based on deduction. So you might say the mammals example would be fine. So to explain the mammals example in first order predicate calculus, you would say for all x where x is a mammal, and then you draw an arrow, which means implication. That implies that x has hair, or has hair as a function with x in parentheses. So if the has mammal function can run on x is true on the variable x, then the has hair function is also true on the variable x. Does that make sense?
Yeah.
Yeah, so that's first order predicate calculus. Now you can say, let's say x is Patrick, and let's say is mammal Patrick is true. And if following first order predicate logic, you can deduce that has hair Patrick is also true based on the law that we set up, the inference that we set up. So, with all that said, Prolog is a programming language specifically targeted at implementing first order predicate logic and doing deductions.
So what does the first order means there? It means you don't make two jumps in conclusion. It means you just make one. Is that what the first order means?
I used to know this. Let me look up.
No, it's okay.
Well, here you could talk about maybe the history of Prolog, and I'll look up second order logic.
So Prolog's actually pretty old. It's not new. It's been around for a while, since the 70s. It was invented by a guy named Alan. Oh, I'm gonna mess this up. Kolmoror and Philip Roussel. And I think it was really, like you said, it's a computer scientist paper. So I mean, there's a lot of people kind of doing this kind of logic and this kind of reasoning and saying that computers should be as well. And so somebody actually finally came up with the idea of having this programming language to implement it this way called Prolog. And they were able to do that. The first ones were, we talked about this before early. It was an interpreted language. Later, kind of people were able to figure out ways of actually like doing more compilation type stuff. And it kind of grew over time. It's been around. I mean, it's still used a lot in universities and stuff, and it's never really faded away and kind of gone away like some languages do. But it's never really gone mainstream, I don't think. I mean, it's never had a time when it was the most commonly used, or even a significant portion of programming was done in it.
Yeah, I mean, there was actually a time when, and there's some people to this day who believe that first order predicate logic is the key to sort of unlocking all the mysteries of the universe. And this was sort of the key to reaching human level intelligence. So people in the 60s and the 70s really believed this. And You'll find guys like Minsky and whatever that still kind of believe this. They're very kind of set in their ways. And but you ever see like Space Odyssey 2001, that movie with Hal, the robot, who
No,
takes over the
but go
ship?
ahead.
Oh, okay. But yeah, basically in the 60s and the 70s, in fact, several famous computer theoreticians are quoted as saying, we'll have human level intelligence within our lifetimes, implemented in the computer. And so there's a time where people believed that deduction and induction were the key to getting human level intelligence. And of course, now we understand that that's not the case. The that knowledge itself involves very high level structures. And this sort of gets us on a tangent. But regardless, during that time, Prolog and other predicate languages were extremely popular because a lot of people with a lot of money believed that they were going to get human level brain-like intelligence from them. But yeah, since then, it's really kind of died down in popularity. But they do have their applications.
So that's interesting. So the knowledge thing. Now, we should kind of point out here that your background is in artificial intelligence. So this is right up your alley.
Yep.
Not so much up mine. So if I sound like an idiot, it's because I am on this topic.
Well,
Anyways,
it goes both ways. Like with assembly, we were definitely we're asking you how
showing
to add,
the strengths.
So.
Everybody has their kind of strengths. So
Yep.
so this is up your alley. But now I know a lot people talk about expert systems.
Yep.
How does that tie into what you're talking about knowledge and about people trying to be as smart as humans or have computers
definitely.
be as smart as humans?
So let's talk about the answering your question from before, first order versus second order.
Yep.
Yeah, so first order logic, all the variables are either all or one. So in other words, I could say if any person is a murderer in the room, then everyone is a suspect. So it's like I don't know who the murderer is, but there's a murderer somewhere in this room. Everyone is a suspect.
Okay.
Once you get to second order logic, then you get into things like sets. So in other words, for all people who are the set of people who went on this trip, then like those people could be murderers. You get into just really complicated. It's called nutrosophic. So it's based on heuristics, but probabilities. So in other words, for everyone who went to the Giants game, half of them experience this. And so now you have this bifurcation. You have this set. So second order is very complicated and very limited. But first order is really kind of where it's at in terms of doing things that are practical.
Okay.
So So what was your second question?
My second question. So expert systems.
Right, expert systems. So by definition, expert system is one that uses deduction and different rules to create a lot of facts. This is the core of an expert system. So
Prolog is the core of an expert system, or the deduction reasoning. I missed
definitely.
what this is.
Right. So for example, you might think of a medical. This is a good example. Is medical, not guessing, but medical diagnosis.
Okay.
So for example, have you seen these flow charts where it's like, figuring out what illness your kid has. Like, if your kid has a runny nose, but then
on WebMD, that happens on WebMD. If you go on WebMD, it says click on the body part where the problem is.
Yeah.
Then you
so
click
it's
on
like,
it.
So if your kid has a runny nose, then it asks you another question like, does your kid have rashes? And if he does have rashes, then he has this disease. If not, then he just has a cold or whatever.
Yeah,
Right.
yeah.
So this is an expert system where they're collecting facts. You can think of this in first order predicate logic. So in other words, there's a first order predicate rule that says, if x, so if the function runny nose for x is true, and the function rash for x is true, that implies that the function, I don't know, has measles is true. Right, I'm just making these up. Don't ever diagnose your kid with this podcast. But
this is not medical advice.
Yeah, so that is an example of a set of rules in first order logic, and then going through and saying, hey, Johnny has a cold and Johnny has a rash, and then traversing through these rules to discover that Johnny has measles is true. That is an expert system.
Okay.
Now, there's two ways to implement an expert system. One is through forward chaining and one is through backward chaining. And so we'll talk about both of these. Backward chaining starts at all of the goals and goes backwards. So for example, going back to let's start with forward chaining because that's easier. So with forward chaining, you would take, let's say, let's make this a little bit more complicated. If somebody has a runny nose or if somebody has measles and they have, I don't know, constipation, then they actually have something else. They have avian flu, let's say. So you put in the facts. Johnny has measles, he has constipation, or no, sorry, Johnny has a runny nose. He has, what was the other thing for measles? Oh, he has a runny nose, he has a rash, and he has constipation. Those are the three facts that you put into this WebMD, this expert system. And it goes forward and it says, hey, if Johnny has measles, therefore he has this this other thing, then he has avian flu. But it doesn't know that Johnny has measles yet because it hasn't inferred that yet. That's a different rule. So it skips that rule. It says, well, we can't apply this rule yet. All we know is that Johnny has a cold, he has a rash, and he has constipation. He doesn't have measles yet. So skip it. So it goes to the next rule and it says, does he have a cold and a rash? Oh, he does. Therefore, he also has measles, right?
Got it.
Now he has four things. So then it goes back over again through the rules. And when it gets to that rule where if he has measles and constipation, that rule also fires. And then now he has the avian flu one. So that's forward chaining, where you're taking your facts and you're finding how many of the rules fit, creating new facts based on those rules, and then just repeating this process. The problem with this is, the rules might explode exponentially. So you might end up inferring just tons of things which might have nothing to do with what you want. So for example, let's say you wanted to know, does Johnny have the avian flu? And you don't care if he has measles or not. Like, you just want to know this one answer to this one question. You could start there and go backwards. Like, you could say, somebody, anybody, not necessarily Johnny, but a person has the avian flu if they have these two things, which was measles and constipation. And then you could say a person has measles if they have, cold symptoms and a rash. And you could take the cold symptoms and the rash and substitute the measles with those two things. You see what I'm saying? So you're kind of going backwards and substituting things in, and you're generating this one like mega rule.
Seems like you're doing less work that way too. So you don't have to go through all the rules trying to figure out if they apply.
Yeah, definitely. So, backwards chaining works when you want to find one answer, and forward chaining works when you want to just figure out what answers are out there. And so, as you can imagine, you can make tons and tons of rules. And people did this. There's something called CYC. Let me see what it stands for. It's called OpenCYC. It's just called CYC technology. Anyways, basically what they did was they generated tons and tons of rules. And you can go to opencyc.org and you can actually download the rule database. And these people actually got experts in every single discipline and generated millions and millions of rules. I mean, this was in the 60s and the 70s when people thought that they were going to end up with a brain when they finished this project. And so literally, like, they called ballerinas, famous ballerinas, and they said, give us facts about ballerinas. And they would say, well, ballerinas have strong feet and strong legs. Ballerinas can jump high. They just kept loading the system full of facts. And then it's almost like if you've ever read Hitchhiker's Guide to the Galaxy, right? They just load the system full of facts. And then the expectation is you can say, should we increase the taxes? Or should my wife and I have another child? And it will somehow use all of these facts and infer, well, based on ballerinas and everything else, you shouldn't have a child or something like that.
So I take it this didn't work out so well because I've never seen one of these machines down at the store where I can buy one or use it.
Yeah, exactly. It turns out that, as Patrick said, I've, versed history in AI, but to keep it short, basically predicate logic and rules like these are not the way that knowledge is stored in your brain. It's much less opaque, right? I mean, think of like a floor, like when you do navigation around your house or your office or things like that, you don't have a floor plan. Like you don't really know the thickness of the walls in your house if you think about it, or the distance, from the wall in your bedroom to whatever room is on the other side, the thickness of that, the distance of that between those two
18 feet
walls.
6 inches.
18, that's a pretty thick wall, man. You should have another room there. But yeah, you don't know this, right? So it's the way that you navigate in your house is much cloudier than that, and it doesn't really use rules. So
You don't
yeah,
know in
needless to
advance
say,
what you want to know.
well,
You
that's
find it.
another thing, true, right? That's another thing is that you have to sort of learn on the fly, and you're constantly generating these rules and tearing some down, and using second order logic. Some of the rules, might exist, but you're not sure. So in other words, if you see a ball falling to the ground and it looks shiny and has that kind of like marble-ish texture, you're pretty sure it's a bowling ball and it's going to go wham when it hits on the ground. But if you see a ball that's around the same size but it has bumps on it and lines like a basketball, you kind of think that it's going to bounce. And if basketballs didn't bounce, over time they would train you to think the opposite, right? So you're constantly building these models that are based on statistics, not based on logic.
Mm.
But nonetheless, Prolog is still extremely useful for building these logic-based systems because you think about it, the thing that it's doing is it's searching through all these rules. It has a bunch of facts, and you could think of the facts kind of like searching through the facts, kind of like searching through anything, the internet, or searching through doing pathfinding. It all comes down to sort of exploring your options and finding out what the future is like and what other options are out there. And Prolog has a sort of a built-in search engine that is extremely, extremely optimized. So because
So
of that, it is very useful.
So it sounds like there's almost two phases here. I guess it's a little bit different than most programming, but you got one where you're kind of building up these statements, these truths, this knowledge, and another one where you're querying it for something.
Yeah, exactly. That's a huge part of it. So, Prolog is it's all about, generating the Prolog files with all of your facts and your inferences, and then, as you said, going through later and saying, I'm going to give you so you have essentially one thing that makes Prolog confusing to new people is that it doesn't differentiate sort of these permanent facts like, if all mammals have hair and things like that from different statements that you make on the fly, like Patrick is a mammal or something. Like Patrick is a mammal is only useful for that instance where you're talking about Patrick. Once you're talking about John, the stuff about Patrick doesn't really matter. And so that's sort of the key to all of this. And that's something that Prolog doesn't quite handle that well, which makes it hard to use. But it's definitely an important part of it. And one thing that's important to note of Prolog is it's Turing complete. So I don't know if we really talked about. Have we mentioned Turing complete?
Yeah, I don't know. We might need to save that for another because that could bear a whole lot of
Yeah, that
discussion.
really gets into. But let's suffice it to say,
You can write any
oh,
program that's writable in Prolog.
exactly. So, and
But it
that's
makes no
true of.
statement to how hard or easy it is to write it or how long or fast or slow it might be.
That's right. That's right. So, you can actually implement sorting. You can do file I/O. You can do anything in Prolog that you can do in another language, but keep in mind that it's geared to doing this first order predicate logic. This gets into something a little interesting, which is the idea of bindings. And we haven't talked about this either, but I'll just mention it briefly. Many languages have bindings for other languages. And so what that means is, let's say I'm writing some kind of application to do an expert system. Like this WebMD is a perfect example. So, the expert system part where I collect the facts of the patients and I make inferences of whatever, ailments they might have. You want that to be done in Prolog because you don't want to have to write your own expert system in C or C++ or Java. Prolog does it way better than any of us could ever do it. But at the same time, you're writing an application for the web. So, I mean, it's going to be done in JavaScript or on the back end in a web server like Python or C++. So, Prolog has what's called bindings, where you can create a Prolog environment and run Prolog functions from inside of another language. And many languages have bindings for other languages. You can write C code inside of Java. You can do there's something called Swig, which takes C or C++ code and generates bindings for something like 20 or 30 different languages.
Yeah, we've talked about
Um,
this a little bit. I don't know if we ever said specifically as called binding, but we've talked about in other languages how easy it is to use them inside of
yeah,
different ones. Yeah.
yeah, definitely. And Prolog is definitely easy to use. In fact, someone has implemented a Prolog interpreter in Python, so you don't even have to use the binding. It's just the interpreter's right there.
So is Prolog interpreted or compiled?
Yeah, so Prolog is interpreted. There are different sort of tricks you can use to sort of pre-compute things, and there's this thing called a cut that you can use, which gets into more advanced aspects of Prolog and sort of adds more sort of, I guess, pre-processing. But yeah, at the heart, it's definitely an interpreted language. And if you think about it, the Prolog is okay. So we talked about MATLAB and how when you're using MATLAB, you might have an operation that says add these two arrays. And that's actually millions of C++ or C, millions of assembly instructions, right? But it's all just one line of MATLAB. Prolog is much the same way, where you're writing these facts, and then you just say one line, like, do I have measles or something? And Prolog's doing all this stuff behind the scenes in C or C++, or as I said, Python has a version. So it could be interpreted without really any penalty because there aren't many instructions.
So are most of the interpreters commercial or open source or?
Yeah, so there is GNU Prolog, which is an open source version of Prolog. There is SWI Prolog, which is by far the most popular. That one isn't open source, but it's extremely fast. The resolution engine is just insanely fast for that one, highly optimized. I think are there any more that you can think of?
Mm-hmm.
There's JI Prolog. I believe there's a Pi Prolog, or maybe it's called Pylog. Let me look it up, just so we don't make our third
No,
mistake.
it's
Oh, it's
okay.
actually called Pythologic. But yeah, that's a module for Python that gives you the Prolog interpreter.
So I would imagine that Prolog is used for kind of things like we already been alluding to, like kind of or were used for like medical diagnoses things. I know I also saw that they were used some for air traffic control stuff where there's a
Yep.
lot of kind of rules about how something should be handled.
Yeah, definitely. I mean, anytime you have a bank of rules, I know that at university we actually developed a Prolog theory creator. And so this is really interesting. We input a bunch of theories and observations that were known to be true, and then it automatically just used its deduction engine to come up with new theories. So, I mean, I'm just making this up, but if you know that, uh, like I don't know, all graphs, with this many vertices also have this other property. And graphs with this third property have X vertices. Therefore, graphs with this property have that property. Just things like that. And it actually came up with just hundreds of new theories. And it was really, really interesting. And papers were published and things like that. And so you feel a little guilty publishing a paper with a theory that you wrote a program to create. But then on the other hand, we published like tons of theories with one paper, so we felt like it was justified.
Yeah,
But yeah,
it's pretty
Prolog was
popular in Asia, right?
yeah, Prolog took off big time in Asia. It's actually still pretty popular. But other than that, here in the U.S. it's mainly just people use it for geeking out. It was used to create Erlang. So
Okay,
programming
yeah, we talked
language
about Erlang
inventors.
before.
Yep, programming language inventors like Python. I mean, sorry, like Prolog.
Okay.
Again, the key strength of Prolog is that it has this inference engine that does all this deduction. So and it has it extremely optimized. So one thing you can think of this in terms of numbers. It doesn't have to be facts. So for example, let's say navigating a maze. You might say, if you are in this spot of the maze, then you're one square away from, any adjacent spot that you can get to that's not, blocked by a wall. So you can just fill in these rules. You can even write another program that generates the rules, that looks at the maze and generates all the rules for all the adjacent tiles in your maze. And then you can just say, I am in this square. Is it possible for me to be at the finish line? That's actually another thing that we should mention is Prolog doesn't just give you yes or no answers, but it also will tell you how it gets there. So going back to like the measles example, you could say, do I have avian flu? And it says yes. But then you can also say, well, how is that possible? Here are my symptoms. How did you figure it out? And it'll say, oh, well, I followed this rule and I followed that rule and I followed this rule and then I deduced this. So you can use that trail that it left behind to sort of navigate a maze or to do robot control or many other tasks.
Yeah. People, I remember doing somebody told me they did a Sudoku solver in Prolog that way.
Yep.
So all the rules about how to figure out the next number in a Sudoku puzzle.
Yeah, I mean, Sudoku is perfect for this, right? Because you have different facts. Like if I have a 1 in this row, then I don't have a 1 anywhere else in the same row. And so these are all just facts. You can write a meta program. You can write a script in Python that just generates all the facts for Sudoku. Generates all the inferences for Sudoku. And then give it the facts, which are the numbers that already exist in the puzzle, and tell it to go. And it will very quickly generate the solution. That's the big thing I want people to get out of this is you can write your own inference engine very quickly. You can just say, here's all my facts. Let me just go through all the rules, find out which ones are true, and then go through all the rules again. You can do that, but it will take a very, very long time. And I don't want to get into the specifics because it gets really complicated, but basically the Prolog guys have made this extremely, extremely fast. And their program, if you write it in Prolog versus make your own, dumb inference engine that just looks at all the rules, it will just run, I don't even know, thousands of times faster. So the inference engine is key. But Prolog does have some weaknesses.
Yeah. So this doesn't sound like it would fit, with the way computers work naturally. Doesn't seem like a good fit. I guess I guess you even have it in the notes the von Neumann architecture, the way computers are now with an instruction line, data lines, registers, and a processor, and trying to do just streams of math instructions. It doesn't seem exactly how this would work.
Yeah, that's so true. I mean, look at the example we gave where you want to check all these rules. Ideally, what you'd want is to just check all the rules at the same time. Like you don't have to go one rule at a time. You can just say, look, here are all my facts. I want to check every single rule and find out which of these are true. But like I don't have to check them in any order. I just want to check all of them. And then now I have a new set of facts. Now I want to just check all the rules again. So you think about your brain again. Your brain is completely decentralized. So in other words, all of the neurons in your brain are all acting independently of each other. And the fact that you only consciously think of one thing at a time or a handful of things at a time is just because those sets of neurons are sort of dominating. But in the background, in your subconscious, you're thinking of just hundreds, thousands, millions of other things. And you're building up millions of inferences. Everything you do is adding more to this massive inference engine that you have, and everything you see. So this doesn't really fit, right? The way computers work now, they execute one instruction at a time. We talked in the assembly podcast about cache and registers and things like that, and the computer can only hold at the core 16, 32 numbers at a time. And it can only operate on several of those and only do one instruction at a time. So this sort of makes makes Prolog extremely slow. So this goes against the nature of Prolog, which is that you have just all these rules and that the order doesn't matter.
Yeah.
So if you could implement Prolog on a brain, it would probably run much faster. But given that computers are the way they are, it just doesn't really fit. The language doesn't really fit with the environment that you're programming in.
Yeah, it seems like it'd be hard. Like I can't imagine trying to write a GUI in Prolog.
Oh yeah, I mean anything that requires you to do things in sequence sort of just is going against the nature of the inference engine. Like the inference engine wants to search and it wants to search everything. And if you want to have a certain recipe, like let's say you want to take a number, add 10, then divide by 2 and then square it. Well, then you need to create an inference for each of those. You need to say, okay, here's this number and it's in stage 1. And if a number is in stage 1, then you add 10 to it. Or if a number is in stage 1 and you add 10 to it, now it's in stage 2. But it's going to be looking at the stage 3 and stage 4 rules when it implements that one to see if there's anything else that matches.
That's not going to be efficient.
Yeah, it's going to run extremely slow. It just cannot do things in sequence because of its nature. And so, yeah, I mean, a GUI or, anything that's like time-based or any type of like matrix math or anything like that is just going to be just brutally slow in Prolog.
Yeah, and I guess that's not really a weakness. That's just not what it's used for. I mean,
right.
A weakness, yeah. We're stretching a little here maybe to say what weaknesses are for those, but that's okay.
Yeah, that's true. I guess, to be more broad, the weakness of Prolog is just that it has very specific applications.
Yeah, that's right. It's very specific purpose.
Yeah, that's right.
And that and even in that purpose, though, it tends to be slower than maybe desirable.
Yeah, I would agree with that. Yeah, I mean, in many of the expert systems, something like Prolog is almost overkill. Like the WebMD. How many rules do they really have? I mean, let's say they have
638.
Seriously? Oh, you make. I was like, man, Patrick's foo is incredibly strong. His Google foo is epic. Let's say they have 638,000 rules, right? Now you're starting to approach a space where Prolog is starting to become useful, but most systems you can just, implement it in C++, or, they have different inference engines now in many languages, and so Prolog is, I would say the applications are just too specific. Like you really, other than geeking out or unless you're really concerned about speed and you have just tons of rules, Prolog really has very limited use. But with that said, it is extremely important to learn Prolog because just understanding, predicate logic, why it's important, and just, if nothing else, to understand, people like the smartest people in the world 30 years ago, 40 years ago, thought that Prolog would create a human brain. And just let that detonate in your mind for a second. People, Minsky and all of these guys thought that Prolog was going to get human level intelligence. And I think just accepting that was the state of things and just knowing that, I think is important.
Yeah. Well, I certainly learned a lot. I mean, I didn't know a lot of this stuff before. And I'm going to go write up a bunch of rules and ask the Prolog what the purpose of the universe is.
That's right. 42.
Yeah. I think I messed that quote up a little, didn't I?
No, I think you got it right.
What's the meaning of life, the universe, and everything in it?
Yeah, that's right.
There we go. We'll get it right.
42.
Okay, anyways, that was geeky. You got any wrap-up notes? Thank you for everybody who's been, rating us in iTunes and writing reviews, and we've gotten a couple more emails, so thank you for all of those. Continue to do that. If you want to send us an email, programmingthrowdown, one word, @gmail.com. You can check out our website at programmingthrowdown.blogspot.com. I know most people seem to be getting this through iTunes, but we do post show notes there, links to the articles we talk about. Not as exhaustive as could be, but can also write comments about an individual show.
Yeah, definitely. I think that once we get our invites for Google Plus, we can we'll have a Google Plus. We'll put Programming Throwdown on Google Plus, and you can add it to your circle, and we'll post on upcoming shows and let you know. Some people didn't know we were out for about 3 weeks when we usually do a show bi-weekly. Yeah. Because we were both going through moving and being sick and things like that. And so the blog sort of keeps people up to date, and also is a way for people to sort of tell us sort of what they want to hear. So we got some feedback for different things. Some people want to talk about games, want to talk about different platforms, and I think we should kind of we might start doing at the beginning of the show, right after the news, talk about a certain aspect like games or like frameworks or something like
Okay.
that. So yeah, we might tackle
Yeah,
something
I
like
think
that
we'll
in the
probably
future.
think about a little shakeup of the format.
Yeah, if you have any suggestions, definitely let us know. If you think that we should cut the news a little short and talk about a specific topic that you have interest in or want to know more about. Patrick and I are pretty eclectic when it comes to programming stuff. We've done just about everything between the two of us, so we could definitely talk about just about anything. So
All right. Well, I think that's it.
yeah,
All right.
so
Till next time, guys.
yeah, have fun with Prolog. The intro music is AXO by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share Alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, and adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.